Okay, so this video is going to start on page 30. So we're going to talk about conservation of energy with actual diagrams. So it says number 1, the diagram above shows the 5 different points on a roller coaster. List the points in order from the point where the car would have the greatest potential energy to the point where it would have the least. So remember, potential energy equals height. The more height you have, the more energy you have. So the highest point would be A. That would be the highest point. Okay, then my second highest would actually be E. Okay, then it goes to B, then D, then C. Okay, so remember, potential energy has to do with height, so start at the highest and then work your way down. Okay, so if height goes up, that usually means velocity goes down, okay, which equals more potential energy. Now list the points in order from the point where the car would have the greatest kinetic energy to the point where it would have the least. So remember, kinetic has to do with movement or velocity. Oops, could have spelled that one right. Okay, so velocity. So at the top of the roller coaster at point A, you don't have velocity. What you're doing is you're building that potential energy, and then usually you have the fastest at the bottom of that hill. Okay, so we're going to start at the lowest and work our way up. So C would be the lowest, so that's the highest kinetic energy. Then D, then B, then E, and then A. Okay, so when you decrease height, usually your velocity goes up, which equals more kinetic energy. C, compare the two lists to each other. What do you notice? Okay, they are opposites of each other. Okay, so kinetic energy, potential energies are opposite. So if you just look at A and B, you just went backwards. Okay, so, and we'll do some more here in just a second. We're actually going to use numerical values now. Okay, so one thing you need to know here is mechanical energy. Mechanical energy is your total energy. Okay, and it never changes. Because remember, conservation of energy. Conservation means to conserve. So your mechanical energy is going to stay the same the entire time. Okay, so if you can find mechanical energy, that actually helps out quite a bit because you know it never changes. Okay, so in part 1, I know that mechanical energy is 50 joules. So that means that mechanical energy is going to be 50 the entire time. So you can go ahead and mark these as 50. Okay, now mechanical energy equals potential energy plus kinetic energy. Okay, so mechanical energy is never going to change. It's the potential and kinetic that can go back and forth. So in number 1, I see my total energy is 50 and my kinetic energy is 10. So what plus 10 would give me 50? Well, that means my potential energy would be 40 joules. Okay, so number 2, potential energy is 50 joules. Okay, and my mechanical energy is going to be 50. So 50 plus what equals 50? So that means I have 0 joules for kinetic energy. Diagram 3, okay, I have 25 joules. Okay, so 25 plus what gives me 50? So that means I have 25 joules of kinetic energy. 4, my potential energy is 0. Okay, so that means my kinetic energy has to be all 50 joules. Okay, and then number 5, what plus 35 gives me 50? So that would be 15 joules of potential energy. Okay, so that was how to do that one. So now let's actually go on to a little more. We got to do a little bit more solving on page 31. Okay, so again, remember that mechanical energy never changes. Okay, so I've got a bunch of missing points, and then I want to find the velocities of each of these 3 locations. Okay, so if I know my mechanical energy is 15, okay, right here, I'm going to go ahead and put 15 joules in all these boxes. Okay, so then I can actually start figuring out what my missing piece is. So at part 1, my potential energy and kinetic energy have to equal out to be 15. So that means 0 plus 15 would be my kinetic energy. Now point 2, my potential energy is blank, kinetic energy 7, so what plus 7 gives me 15, so that'd be 8 joules. And then if you look at point 3, all 15 joules is potential energy, so that means my kinetic energy is going to be 0. Okay, so I filled in my missing pieces. So now I actually have to find the velocities at each point. So at point 1, okay, I'm going to do KE. Remember, KE equals 1/2 mv squared. Okay, so I'm going to plug in. So I know my kinetic energy right here is 15 joules. So 15 equals 1/2. Okay, so my mass up here, we said the skater is 20 kilograms. Okay, so my mass is 20. My velocity, I don't know, so I'm going to use velocity squared. Okay, so get V by itself and then square root both sides, and we get a velocity of 1.2 meters per second. Okay, point 2. Okay, I know my kinetic energy is 7 joules, so 7 equals 1/2. My mass is still 20. Velocities, we're just doing the same thing again, just with a different value. Okay, so I'm going to get V by itself and square root both sides, and I get a velocity of 0.84 meters per second, which should make sense because we are starting to go uphill. Okay, so your velocity should be going down and your potential energy and height is going up. So at point 3, if you notice, my kinetic energy is equal out to 0. Well, if I have 0 kinetic energy, that means I have 0 movement. So that means my velocity is 0 meters per second. Okay, so again, I can't stress this enough, is that height increases your potential energy. Okay, velocity. Okay, if velocity is going up, that means kinetic energy is going up. Okay, but mechanical energy, always the same. Okay, let's move on to the next page. So this one's actually got a little more calculation involved. Okay, so calculate the potential energy of kinetic energy, mechanical energy, velocity, and height of the skater at various locations. So we got a lot of things going on here. Okay, so first they told us the mass of the skater right here, which is 60 kilograms. So let's just kind of figure out what we can do. So at point 1, we'll see what we can fill out. We know we're on the ground. Okay, so if we're on the ground, it means we have no height. So that means potential is going to be 0 joules. So we can go ahead and fill that in because we have no height. Okay, so I did get a velocity. Okay, my height is 0. So what I can do now is I can actually solve for my kinetic energy, because kinetic energy has to do with 1/2 mv squared, and I know my V. So kinetic energy equals 1/2. My mass is 60. My velocity is 8. And that is squared. Okay, so that comes out to be 1920 joules. So I can go ahead and fill that in. So 1920 joules. Okay, and then I know my mechanical energy equals kinetic plus potential. So mechanical energy equals potential plus kinetic. So my potential is 0 plus my kinetic is 1920. So that means my mechanical energy is going to be 1920 joules. So you just solved right there the total energy the entire time. So 1920 joules can be put at every single spot for mechanical energy. So we can go ahead and fill those in. Okay, so we've solved everything at point 1. Okay, so we're done there. Okay, we found mechanical energy that's going to help us solve everything else later. Okay, so let's move on to point 2. So point 2, we know my mechanical energy is 1920 joules. Okay, we are also given a height. Well, if I was given a height, okay, that means I can find my potential energy. Okay, so we're going to find potential energy first. Okay, so potential energy equals mass times gravity times height. So mass was 60, gravity is 9.8, height is going to be 1 meter. Multiply that out, and you get 588 joules. Okay, so there's your potential energy right there. So you can put that in the box, so 588 joules. Okay, let's move on to the next one. So I can find my kinetic now. Even though I don't have a velocity, I can find it because, remember, mechanical energy equals kinetic energy plus potential energy. Okay, so I'm going to set that 1920 equal to kinetic, which I don't know, plus 588. So subtract 588 from both sides, and I'm going to get 1,332 joules. Okay, so now I know my kinetic energy, so 1,332 joules. Now, only thing I'm missing now is velocity. Well, now I know my kinetic energy. So now I can do this. I can set that equal to my equation for kinetic energy. So 1,332 joules equals 1/2 mv squared. So mass would be 60. Velocity, I don't know. I'm gonna leave it as v. Okay, get v by itself and then square root both sides. I get a velocity of 6.7 meters per second. Okay, so now I can fill that in. So 6.7 meters per second. Okay, so part 2 is done. So now all we got left is part 3. So part 3, we have mechanical energy. We have velocity equals 0. So that means I've reached the top. Okay, so at point 3, that's as high as we're going to go. So if velocity is 0 meters per second, that means kinetic energy is also going to be 0 meters per second. Or I'm sorry, not meters per second. My velocity is 0 meters per second. That means I have 0 joules for kinetic energy. So I can go ahead and put 0 joules for KE. Now we know mechanical energy equals KE plus PE. Okay, I keep writing this equation down just so you can kind of get that stuck. Okay, I know my mechanical energy, my total is 1920. Kinetic energy is 0 plus PE. So that means my potential energy is going to be 1920 joules. So basically all the energy is shifted all towards potential energy. Okay, so I can put that 1920 joules, okay, at PE. Okay, only thing I have missing now is height. Well, luckily I have potential energy now, and I can set that equal to the equation. So I can set 1920 equal to mass times gravity times height. So mass is 60, gravity is 9.8, and height, I'm gonna leave it as h. Okay, solve for h, and I get a height of 3.3 meters. Okay, so there is my new height. So if you notice here, what you're doing is 1920 joules stayed the same the entire time, but what you're doing is you're shifting. Okay, so down at the bottom, you have very high kinetic energy, high velocity, and you basically have no height. Okay, so no potential energy. Now, as you start going up that hill, what's happening is your kinetic energy is going to start going down, and your potential energy is going to start going up. Okay, mechanical stays the same. All you're doing is just shifting to another type of energy. And then at point 3, if you notice, your potential energy is all the way up and kinetic energy is all the way down. Okay, but regardless, the entire time we have the same amount of energy, it's just shifting between the two. Okay, so that's going to end page 32.